Maybe we can start, because I remember what I want to say in the first slide. It's about standard progress. Everybody know that currently we finished the first release. We call it release 15 September or the June of 14th, whatever. And everybody knows that this release 15 is focusing on the enhanced mobile broadband service. And the other service like ultra-reliable, low latency, and massive machine type of communication will be addressed in release 16 and 17 or later. And when we talk about the enhanced mobile broadband service, it's still focusing on the consumer market. Does that, you see, I started working on 5G like 4 years or 5 years back, 2013. That time, standardized is still in the starting point. When people talking about 5G that day, everything can be connected, from the fish in the sea and the bird in the sky, just like a fiction story. But now, since the first release 15 is there, some of the operators like Korea, Spain, UK, and some other like Czech, Slovak, these kind of countries already have the commercial spectrum in their hand. And the local operator willing to pay the money for 5G deployment. We have to focus on the real business. So when we talk about the real business case, I'm quite positive about the enhanced mobile broadband service. Why? For example, unlimited package. This is quite popular these days. An unlimited package stimulates the usage of data. For example, like in Kuwait, the DOU is about 70G, 70G. I don't know what application they use to consume such huge DOU. In China, DOU is still in this curve, starting from like 2G of last year's to 5 or 6G this year's. This is good things for the operator, but also have a very negative impact on the network performance. I have some comparison. For example, like in some hotspot, Shenzhen, the local downlink experience dropped to the 4 megahertz. The uplink is just like 400 kbps. What to do? How to secure the performance of the users? Either expand your network of current technologies or go for 5G. Some of the operators thinking about use 5G, for example, like BTEE, some other like Korean-based operator, where the consumer market is still huge. So enhanced mobile broadband service is quite promising. And but doesn't mean that we will stop exploring new opportunity, like connected car, smart manufacturers, which will be addressed in release 16 or 17. But the question mark is that I don't think the technical issue is difficulty. I believe that technically we can address the issues of ultra-reliable, low latency, and massive machine type communication. The problem is the business case. For example, like connected car, 5.9 reliability, 99.999%. That means you have to double lots of connectivity. For example, you have to double your wireless connection. Suppose that one breaks down, the other can take over. You have to double your transport. So much so to make sure that one breaks down, the other take over. Battery, every infrastructures, you have to double or quadruple or triple. So much so to secure the 5.9 reliability. This means money. But who pay for that? The vendors, operators, the verticals, or the average people? Currently, no answer. I think the business model is the big question mark for the moment. So that's why we say that the real use case for ultra-reliable or low latency or massive machine type communication, we have to wait for a while. At least, I think, after 2020, we can see the rising of this kind of a vertical application. But When we look at architectures, I think the good story is that currently the standardization already defined the non-standalone and the standalone. Non-standalone majority for the enhanced mobile broadband service. The only difference between the 4G and the 5G non-standalone is that you add new G-Node B 5G new radio. And the standalone, you use the 5G new core. After that, the architectures relatively remain. You don't have to change your hardware currently. So much so you don't have to change all of your hardware for the future application, for example, like ultra-reliable low latency and massive machine type communication. And this is the question mark I was quite often being asked by the operators. What if I deploy the non-standalone in the first place, and like 2 years later, I go for the standalone? Should I or have do I have to change all the new radios currently we used for the non-standalone? As a vendor, Huawei's answer is no. To shift from non-standalone to standalone is just about add new cores, and it's just about software upgrade for the new radio base station. So you can protect your invest on the access network. And I stay the first page quite long. Let's move to the second. You see, these days, the other issue being quite often asked is about the security of 5G. I think the audience in these rooms is all experts. We know that the security issue currently being raised by several countries is not about the technical. Technically speaking, 5G is more secure than before. Why? If you use standard body, lots of specification, lots of standard have been proved to strengthen the security of 5G. Later, I'll have slide. I have a full highlights what we've been doing for 5G to make sure that it's safer than 4G. And this slide to help you to understand, if you're using 4G and you think 4G is relatively safe, 5G is equally safe or even safer. Looking at the protocol stack, both 4G and the 5G had a PHY layer, MAC layer, RC layer, PDC, CP layer, and RC layer. Furthermore, 5G add SDAP for the QoS flow control. So that's why we say compared to the previous generation, 5G has share the same architecture with higher speed, lower latency, more connectivity, and better security. Later on, I will explain that with more specific elaboration. This slide is about comparisons of LTE and the new radios of release 15. The values of release 15, having said that, is about to enhance the mobile broadband service, enhance the experience of a mobile broadband service. There are some values to evaluate. Compared to LTE, the release 15 new radio should offer 10 times user experience, and also 20 to 30 times as for the sales throughput. As long as the 5G can offer this as compared to LTE, I think the business is there. This means that the vendors can provide an operator cost per bit reduction by at least 10 times. If you have a new system which can offer higher speed and the cost per bit can get 10 times reduction, nobody don't love it. Am I right? So on the left side, you can see the comparison in terms of the massive MIMO technology, bandwidth definition, air interface technologies, and UE. For example, massive MIMO have been introduced in new radio from day one. That means the first type of a smartphone support massive MIMO natively. Not like LTE. We understand massive MIMO can also apply to, it's a RAT agnostic. It can also apply to LTE, but unfortunately, it'll be introduced in late release, say like release 10. So currently, most of the smartphones don't support release 11 or 12 or afterwards. about 60% of the smartphone just support release 8, and now which can be translated into that this kind of smartphone cannot enjoy the benefit of mass MIMO, but 5G is different. It is native. And the second is the bandwidth. For LTE, just define the 20 meg or below the bandwidth carriers. But 5G, we define the 10, 15, 20, and the 14, 50, 50, 60, and 70 until 100 for the C-band. And for millimeter wave, the carrier's bandwidth from 400, 800, or even larger. Talking about the C-band, the other question is, what is the major first spectrum for 5G? C-band definitely is popular, is the wave 1. For example, like in Korea, in Spain, UK already auction, the spectrum auction, C-band definitely on the spotlight. But there is also rising of the candidate spectrum, for example, like 2.6. We know that in China, some operator might get the 2.6. And China is such a huge market, can cultivate the ecosystem. And the other possible spectrum is like 2.3. Ecosystem is relatively not that mature, but we still keep close watch on the spectrum. Sub-3 gigahertz is a little bit tricky because sub-3 gigahertz like 700, 800, 900, all of this can go for 5G, but frankly speaking, the bandwidth available is quite short, so it's relatively hard to make it very outstanding as compared to use for LTE. That's why currently, for the moment, people are talking about the C-band 2.6 instead of talking about the FDD bands like 7A, 900 or the others. For 5G, the new air interface, you said, you know that previously we think that 5G is revolutionary. Why we say so? Because air interface use new channel coding, use new multi-access technology, and also use new waveforms, frame structures. All of these technologies we can say it's revolutionary. But when talk about the architecture, I don't think it's quite revolutionary. Let's see the next. Later I will show you why we say so. And the other difference between the LTE and the new radio is the terminal. For LTE, majority of the LTE handset is 1T2R. For new radio, born to be 2T4R. So much so to offer better user experience. Using all of this technology package, we can secure that 10 times user experience enhancement as compared to LTE, and 20 to 30 times of cell capacity enhancement as compared to LTE. So, finish this. The next story is about why we say 5G provides better security than 4G. It's a long story. Actually, if you're looking at the 3GPP standard, that's a long paper. I just summarized 4 highlights. First, use 256-bit algorithm instead of using 128-bit algorithm. This will be introduced in release 16 definitely. And better privacy protection. IMC carry on the locations of the peoples or some private information. Used to be transferred in clear text, but now it will be cipher, encrypted. And also the interconnection security. Introduce a pair of SEPP, security edge proxy, between 2 PLMM, so much so to secure the attack from SS7-like or some other attack. Stronger air interface protection. User plane integrity protection used to be not introduced in our system, say 4G system, but in 5G that will be introduced. So the user plane auto attack will be avoided. So this is the 4 major enhancements of a 5G security as compared to the 4G. As long as we deploy this one by one, I think the security of 5G is better than previous generation. So it's quite confused me that when somebody say that using 5G is dangerous. I think this is nothing to do with the technical. It's about political. Okay. That's for the security. Now for the core network architecture. On the left side, you will see the 4G and 5G non-standalone using the same core network architecture. Both have the MME, S gateway, P gateways, PCRF, HSS. For SA, for the standalone, introduce the SBA service-based architectures. Inside, we can have the function like AMF, access management function, session management function, and authentication functions, network slicing selection function, and some like unified data management, network repository function, and network entity function. All of these components can be composed or decomposed according to the requirements of a different service. This is what we call network slicing. But currently, there the other issue being raised inside 3GPP body, that private network and the public network. There's a different groups. Some say that we still need private network for some highly secure network, for like train, for like car industry, for the car, connected car. But this discussion is still ongoing. Nobody knows what's going on currently. But network slicing still is a very beautiful story. We believe that someday that will come true. And for the ultra-reliable low-latency services, I will briefly introduce what will be done for the air interface and network architectures. For secure the short latency, the air interface will introduce the short TTIs, embedded air interface, and ground-free technologies to shorten the air interface latency. And for the network architecture, we believe that user plane will be separated from the core and put close one down to the ramparts. So much so to reduce the latency. So this is two major adjustments for the network to secure the latency, for example, like to the 5 millisecond or even shorter. Okay, that's about the standard, about the core network, security, or the release 15 values. Now let's talk about the reality. You know, in the past 2 years, we've done lots of tests and trial about 5G Huawei. We do the test in Hangzhou, in Seoul, in UK's, in large scale about massive MIMO. Currently, we saw that massive MIMO really a fundamental selections for the operator to get the 10 times user experience and 30 times of capacity enhancement. According to the trial in Hangzhou, we see that XGPPS, although it's everywhere, can be secure in commercial trial. But we understand if there's much more traffic of a 5G, the data can be more realistic. For example, we can secure that the 100 megabps at edge or 50 megabps at edge. This is our commitment. XGPPS currently is a propaganda. We can do it now just because the load is not that high currently. But remember, 10 times user experience, 120 times capacity enhancement, that is what we can do as compared to the current network, current technology. And for so many years, the operators complain about the massive MIMO, say it's not realistic to be commercially deployed just because the size of massive MIMO is so big. The weight of the massive MIMO is so heavy, it's not possible to install on the tower, on the rooftop, or against the wall. But look at a comparison on the right side, on the left side. The sub-3 gigahertz antenna is on the right. This is what we offer 64 TRX massive MIMO. This is the comparison. So all the obstacles or difficulties about the engineering of massive MIMO have been tackled. So it's time for massive MIMO scale deployment. And on the right side, you can see our real reality. This is what we install on the rooftop against the pole, street light, and we also put the massive MIMO against the wall. You can see everywhere. If you pay visit to Hangzhou, a very beautiful city in China, you can see lots of massive MIMO on the street, on the rooftop, on the stadium, lots everywhere. And also see the news of U+. Yesterday, U+ say in public that they already deploy like 4,100 sites, 5G sites in their network. We are very proud to be part of this project. So if you pay visit to Seoul, just to see the massive MIMO there. That's from Huawei, sorry. Finally, I will finish my parts by this announcement. 5G end-to-end products ready in 30 September of 2018, which means that we can offer you yesterday. If you want it, if you have a commercial spectrum, if you have money in your hand, come to Huawei. Thank you.